Earth's atmosphere constantly holds millions of tons of water vapor, invisibly shifting global weather patterns. This invisible dance orchestrates every raindrop, every storm, and even your daily forecast's accuracy. Weather patterns are predictable shifts in atmospheric conditions that govern our planetary environment. They profoundly dictate agriculture, travel, and everyday life for billions of people across the world. Imagine Earth's atmosphere as a complex, dynamic system comprising countless interconnected forces. These forces, primarily temperature and pressure, constantly interact, creating all the weather you experience. Understanding these patterns helps us prepare for everything from gentle breezes to severe weather events. For centuries, people have observed the skies, trying to decipher nature's intricate atmospheric language accurately. It feels like an impossible task to map these vast, invisible movements and their global implications. Fortunately, simple concepts can unlock this atmospheric mystery, revealing its profound natural beauty. Let's simplify how weather works using sticky notes on a giant, interactive global map. Each sticky note represents a specific parcel of air, carrying unique temperature and moisture data. Warm air, like a light sticky note, rises easily, creating low-pressure zones beneath its ascent. Conversely, cold, dense air, a heavier sticky note, sinks, forming areas of high atmospheric pressure. These fundamental rising and sinking air masses drive all observable weather across our entire planet. The sun unevenly heats Earth's surface, causing some sticky notes to warm faster than others. Equatorial regions receive direct sunlight, creating a perpetual band of consistently rising warm air. This warm, moist air then travels towards the poles, gradually cooling and sinking along its journey. These vast global air circulation cells, like Hadley, Ferrel, and Polar, act as atmospheric conveyor belts. But that's not the strangest part about these invisible, constantly moving atmospheric movements. The Earth's rotation adds another crucial layer, significantly deflecting these moving sticky notes. This Coriolis effect bends winds right in the northern hemisphere and left in the southern. It transforms straight-line air movements into swirling patterns, shaping massive, powerful storm systems. Picture a giant spinning top, influencing every tiny sticky note's precise path on its surface. These deflected winds create predictable global wind belts, including the trade winds and roaring westerlies. They efficiently carry moisture and heat across continents, profoundly influencing regional climates significantly. Ocean currents, vast underwater rivers, also play a huge, often overlooked, role in this puzzle. Warm currents release heat and moisture into the air above, creating warm, humid sticky notes. Cold currents absorb heat, leaving the overlying air much drier and cooler, altering regional weather. Wait until you hear what comes next about how these tiny interactions scale up globally. When warm, moist air meets cold, dry air, it's like two different sticky notes colliding forcefully. The warmer air is then forced upwards, cooling rapidly and condensing its water vapor into clouds. This process forms fronts, boundaries where weather changes dramatically and often quite quickly. Cold fronts bring sudden temperature drops and intense, short-lived storms marked by heavy rainfall. Warm fronts produce gradual temperature increases and prolonged, lighter precipitation over wider geographic areas. Orographic lift occurs when air sticky notes are forced up and over towering mountain ranges. As they ascend, they cool, condense, and drop moisture on the windward side of the peaks. The leeward side, the rain shadow, remains much drier, creating distinct ecological zones below. El Niño and La Niña are massive oceanic events that significantly disrupt global weather patterns. These periodic shifts in Pacific Ocean temperatures can effectively move entire belts of sticky notes. They cause widespread droughts in some regions and heavy flooding in others, impacting countless millions.
And then something unexpected happened as scientists realized the full extent of these connections.
Jet streams, fast-moving rivers of air high in the atmosphere, steer weather systems globally. These powerful currents act like superhighways for storms, directing their paths across entire continents. A slight wobble in a jet stream can entirely reroute a major weather event, surprising forecasters. Understanding these intricate weather patterns is crucial for human civilization's continuous resilience. Farmers rely on accurate forecasts to plant and harvest crops, ensuring global food security worldwide. Aviation and shipping industries depend on precise meteorological data for safe and efficient travel. Emergency services utilize weather predictions to prepare for and effectively respond to severe storms. Urban planners design infrastructure, considering historical rainfall and wind patterns for public safety. Even your daily decision, like carrying an umbrella, stems directly from this atmospheric knowledge. Forecasting models, using powerful supercomputers, simulate sticky note interactions on an immense scale. These complex models continuously refine predictions, improving accuracy daily across the entire globe. Studying these patterns also helps us comprehend long-term climate changes and their future impacts. Our planet's dynamic atmosphere ceaselessly reminds us of nature's powerful, interconnected, and vital systems. From rising warm air to the Coriolis effect, every element works together, shaping Earth's diverse weather. These invisible atmospheric forces, like countless tiny sticky notes, continuously rewrite our planet's skies. If you found this fascinating journey through atmospheric science captivating, subscribe for more incredible insights. Hit that like button if you enjoyed uncovering these weather secrets, and share your thoughts below. Join us next time as we unravel another mind-blowing mystery of our amazing natural world. If you found this fascinating journey through atmospheric science captivating, subscribe for more incredible insights.